All right, welcome back to part 2 of 1.4. I'm on page 20. So let's do another practice at graphing a piecewise function. So we're going to be graphing 3 lines since that's all we've really practiced. And the first thing I'm going to do is address my boundary wall. So I've got 0 to 3, I've got 3 to 5, and 5 to 9. So this time I'm going to start using special colors for each one. So 0 to 3, here's my boundary line of 0, and here's 3. Okay, and then the other one is from 3 to 5, so I'm going to make that orange. I'll just kind of put the orange right next to it here. And 5, that's a really narrow picture frame. And then in blue, I'll do the 5 to 9. So here's just that edge of blue. You get the idea, and then up to 9. And just for a reminder, in this section right here, I'll be putting 4 plus x. In this little stretch, I'll just be putting 7. And in this little stretch, I'll be putting the 9 minus 2/5 x. All right, let's start with our 4 plus x. So in our 4 plus x, just a reminder, b is by itself, it's 4, and the number that's married to x is an invisible 1 here, so we'll have our rise over run. So remember, start on the y-axis. I'm going to begin at 4. I will use a pencil here to erase, and this is a positive line, so make sure it's going uphill. So go up 1, over 1. And if you want to keep going, you can, but realize you only need it for this little section. So there really isn't any point in going further this way or further this way. Let's go ahead and connect those, right? 0 is equal to, so we want to make sure it's closed here. And 3 is not equal to, so we're just going to have that be an open dot. Let's go to the next one, 7. So this is just where you've a line where every y value is 7, and that is a horizontal line. So I can go up to where y is 7. Maybe you want to draw a whole line through, but the part we really want is in between here. So I'm going to really darken that up, and then I'm not even going to continue this way and erase the part that I actually didn't need. All right, with 7, with the 3, it's underlined, so I'm going to actually end up closing this back up. And with 5, I'm going to leave it open. Okay. And then the last one, 9 minus 2/5 x. So there's a couple of ways you could do this. One way is with this 9 minus 2/5 x. You could see that your y-intercept is at 9, and then you got your m of negative 2/5, which your line will be going downhill, right? So you could start at 9. Let's do that. And from there, go down 2 over 5. 1, 2, 3, 4, 5. And I get right where I need to be. I'm going to be starting right there. And then down 2, 1, 2, 1, 2, 3, 4, 5. And I'll just go a little bit out. And then that's actually all I need. This would be better with a ruler. So I'm going to use my note card here. And I went a little further past that blue line, so now I'm going to be doing my erasing. And 5 is underlined, so close circle here and open circle right there, kind of like right in the middle. All right, let's talk about evaluating. And then I'm going to bring up a big question that I tend to get asked. So if x is 1, well, that's easy to do. If x is 1, I can see it's 5. And just remember, if you can't tell on the graph, sorry, yeah, you can see that, you can always go to your function. And since 1 fits in this domain, I could put 1 in here, and then 4 plus 1 is that 5. G of 6. So here's 6, and if you notice, 6 is kind of at a halfway mark. So I could guess and maybe say it's 6.5. But the other option is I could go here and do 9 minus 2/5 times 6. So let's get exact. So I'll do 9 minus 2/5 times 6. So that becomes 9 minus 12 over 5 as a mixed number. That is, 5 goes into 12 twice. It's 2 and 2/5. You could also just type this into your calculator. So 9 take away 2 is 7. Take away 2/5 from that, and it's 6 and 3/5. And some of you are like, what? What are you talking about? That's all stuff that you learned in middle school. But otherwise, just type it into your calculator, and you'll get 6.6 as a decimal, which that seems to be right about 6.6. All right, and then g of 12. So g of 12, if you notice, 12 doesn't have anything in here, so this is going to be one of those that's not possible. And I should also know it's not possible because 12 doesn't fit any of these domain restrictions. All right, let's take a look at the next time. So piecewise, out of all our functions, is actually probably some of the most realistic applications in real life. So if you just take a moment here, for examples, companies will often give a discount on items when you buy them in bulk. Suppose a club wants to print signs to hang around the school advertising an upcoming event. A printing company will charge $1.25 for each sign up to and including 100. That sounds pretty important, so I'm going to highlight that. And then for every sign over 100, they're only going to charge you 75 cents. It's a good deal there. And this will need to be represented by a piecewise function. So the first thing I'm going to do is address these domain restrictions. So notice the language. C is probably the cost, right? And S is the number of signs. So I'm going to be using those letters. So if my sign amount is up to and including 100, that's the same as saying less than or equal to 100. So there's going to be one domain restriction. And then for every sign greater than the 100, I'll have my other equation. So if you notice, looking back up here, we have our domain restrictions, and there's a semicolon, so I'm going to put that here. And then I'm just going to write my restrictions. So it's $1.25 for every sign. So one sign, $1.25, two signs, that's another $1.25, three signs, add another $1.25. So my equation would be $1.25 for each sign that you purchase. There is not a y-intercept because your beginning amount is 0. If you don't order any signs, you're stuck at 0. Now let's take a look at what's going to happen after that. So now for every sign over 100, they're only going to charge me 75 cents for every sign. So for instance, what could that mean? So for 0 signs, I'm not paying anything. For 1 sign, I'm going to pay $1.25. For 2 signs, I'd be paying $2.50. I already said that. 100 signs. Well, 100 fits here. And if you take 100 times $1.25, now you're paying $125. But after that, 101, now I've reached this, and I would take 101 times my 75 cents, which, yeah, let's grab our calculator for that. So 101 times 0.75, I would only pay, at this point, quite the discount, $75.75. And then 122, then I would just, do that math again. Take 75 cents times 102, and you'll get $76.50. Whoops, etc. So, maybe if we did some key points, here's 0. I don't know what else we could do. We could maybe just put like 100 here. And looks like our prices are going up. So we got to 125. We could do maybe like 25, 50, 75, 100, 125. So 25, 50, 75, 100, 125. So from 0 up to 100, right there, I'm going to make a little X. I pay one price, close circle that in, and then after that, it's not going to be as steep. It's going to kind of flatten off a little bit. And if you notice at 101, right past that, now we drop to 75, and then it's going to probably do something like this as well. because it's going to be increasing with an open circle. So here's 1.25s, and here's 0.75s. And again, notice that big drop once you switch over. All right, last problem. Let's see if P be a function that models the cost of a hotel room for P people. So there's the number of people, here's the cost, so that's money. And the hotel charges $85 a night for a hotel room with up to 2 people. So 2 people, you're good. After that, it's $15 per night, and then there's a max capacity of 6 people. So here what's happening is it's $85 a night for 2 people. So this is a flat fee of $85. That's why it's always 85. But after that, it's going to be the 85 plus $15 for each additional person. So those are the equations that I can make. 85 for my flat fee for up to 2 people, and then it's $85 plus 15 for every person. So we're going to write our piecewise function. So notice this big turn would be our boundary line. So we're going to have a price up to 2 or 2 or less. So when P is less than or equal to 2, and then when P is between 2 and 6, 2 is already included here. Sorry, you can't see that, so I won't underline it, but up to 6, including 6, hence that closed circle. And so for this one, put my little semicolon, is just a flat fee of 85, and then this one again is $85 plus $15 for every additional person. Then they would do this little bracket here and put our big C of P equals. Now let's use our function. And this time let's not use the graph, let's just use this. So if it's one person fits this domain. It's going to be $85. 3 people fits this domain, so I'm going to do 85 plus 15 times 3. Well, that's 45, and that would give me 130. So the cost for 3 people is $130. Sorry, you couldn't see that. And 7, well, 7 doesn't work. It doesn't meet my domain restriction. I can't have 7 people in the room, so I'm going to say not possible. Now we're going to use the function to find C of P equals 180. So hopefully you realize that 85 is set. You know, that's from 0 to P. So how many people could I fit for $180? Well, let's see. I would use this function, and this is like my saying y equals 85 plus 15p. So I'm going to get 85 over first. So I'm going to subtract that. That gives me 95. And then if you take 95 and you divide it by your 15, you're going to get that your p should be 6 point. So with 6 1/3 person, so basically with 7 people, you would be charged that much. But again, 7 does not meet our domain restriction, and hopefully you could see from the graph that 180 never would have happened as well. All right, that is 1.4.